So SQL Server implements isolation between transactions using locks. So let's talk about locks for a minute and just sort of explore and figure out how locks work. A lock has three properties. The first is its granularity, or its scope. The second is its mode, and the third is its duration. The granularity of a lock describes how much data that lock is actually locking. So a row lock affects only a single row of data. A key lock locks just one part of an index, because that's where keys live. Keys are a part of an index. A page lock locks an entire 8K page. An extent lock locks 8 pages, or 64K. And by the way, SQL Server does all of its reads and writes as extents at 64K at a time, so that makes sense. And sometimes SQL Server will lock the entire table, and you'll also see database locks. So those are the types of granularities of locks that you'll see most often. And SQL Server has a lock manager, which will actually watch what's happening with the locks and try to adjust the granularity and the number of locks. For example, if SQL Server sees that you're getting lots of row locks, it may choose to escalate those row locks to a page lock. And if you're getting lots and lots of page locks, instead of handling 100 page locks, it may decide to escalate those to a table lock. I've seen some developers who try to use locking hints to control this, and I would recommend not using locking hints, but allowing the SQL Server Lock Manager to do its dynamic locking and to automatically adjust the locks for the best performance. The second property is the mode of the lock. If a transaction is just reading the data, it'll need a share lock. If you're actually performing an update, meaning you're doing a insert, update, or delete, you'll have an exclusive lock. When people are reading, a number of people can read at the same time, so a share lock allows other share locks, but you can't get an exclusive lock while other people are looking at it. So a share lock will block an exclusive lock. And only one person can actually be making a change at a time, so if you're making an exclusive lock, that'll block all the other locks. Then there's also this thing called the update lock. And the update lock has a very misleading name, which is why I didn't talk about it at first. Think of it in terms of this. If you want to do an update, you have to first of all find the row that you want to update. The update lock is basically a share lock that says, hey, I found this row, I'm about to make a change to it. This way SQL Server knows you're about to do an update, and you're there waiting. It keeps somebody else from getting an exclusive lock or an update lock, and as soon as there's no other shares and that update lock can be converted to an exclusive lock, then you get the exclusive lock. So don't think of update as equal to I'm doing an update. Think of update as I'm about to do an exclusive lock, and I'm primed and ready for that exclusive lock. As you see locks, you'll also see lots of intent locks. And intent locks serve a couple different purposes. One is if somebody's waiting for a lock. For example, let's say Joe has an exclusive lock and Jim comes by and wants to get a share lock. Well, he can't get that share lock because it's being blocked by Joe's exclusive lock. But he could get an intent to share and be ready to get the share. So that's the first purpose of the intent lock. The second purpose of the intent lock is to build a hierarchy of locks, and let me explain what that means too. Let's say there's a table which has 1,000 pages in it, and Joe has 5 of those pages locked. When Jim comes by and wants to get a lock, rather than examining all of those pages to see if they have locks, Joe's page locks will also have an intent lock on the table. That way, someone else can come by and just look at just the table and tell someone else at a finer granularity has a lock on this object. So it's there for performance as well. And the locks actually take place inside of a table in memory. So it's not like SQL Server has to scan a lot of memory to figure out what's happening with the locks. But still, the intent locks are there as a performance enhancement for SQL Server. The third property is the lock duration, or how long you're going to hold that lock. And this is where setting the transaction isolation level comes into play. If the transaction is set to read uncommitted, that lock is not going to remain at all. It's going to be there just for the split second to make sure that nobody else gets an exclusive at the exact same time you're getting that exclusive. But a read committed lock is going to remain for the duration until the commit. A repeatable read lock will remain for as long as somebody else has a select. Serializable is special in the fact that it's not only as long as a repeatable read, but it also locks ranges of keys so nobody else can insert within that certain area. So for our example before, where I showed you the phantom row, to block that, serializable would put a key lock on the nickname index to make sure nobody else could even insert in that same range of rows. So that's the three properties of a lock: its granularity, its mode, and its duration. And with that understood, now we can dive in and take a look at some real locks.